Hello everyone and welcome back to our channel Quaint. Today we are stepping into the future of communication, a realm where messages could theoretically travel instantly, no matter the distance. Yes, we are talking about the quantum internet. It's a technology that could revolutionize how we connect, compute and communicate. So question is instant communication really possible, or is it just a quantum myth? So this is the topic of discussion in today's video. You know, the quantum internet, that is not like the current internet. Okay, today's internet relies on classical bits, means zeros and ones, to transmit information through electrical or optical signals. Okay, but if you talk about quantum internet, then in that case it uses actually quantum bits or qubits, which can exist in multiple states at once, thanks to the principle of superposition. You know, superposition, this is this thing you would find in the subject of quantum mechanics, superposition. And due to this principle, existing of quantum states means in multiple states at once is possible. Anyway, the most interesting thing is not superposition here. The most interesting thing is quantum entanglement. And you know, Einstein called it famously spooky action at a distance. And according to quantum entanglement, instant correlation is possible. Yes, say for example two particles are there and distance between them is in terms of few light years. So if you change the state of the one particle, instantly that influences the state of the other. Okay, that means whenever the state of one particle is measured, one quantum particle is measured, instantly that influences the state of the other if they are entangled quantumly. So this is quantum entanglement. But question is, using this quantum entanglement, can we send messages instantly across galaxies? Means if the distance is in terms of light years, then also is this possible? Instant messaging or instant communication is possible? The answer to this question is no. That is not possible by using quantum entanglement. Because the act of measurement is random. We cannot control the outcome of a measurement that you use to encode a message. To send a message, what is the requirement? Encoding of the message is the requirement. But the result or the outcome of a quantum measurement, that is random. You cannot control that thing. Since you cannot control that thing, the outcome of the quantum measurement, so you cannot use that thing to encode a message. That means instant communication using the outcome of this quantum measurement is not possible. That's why instant communication or instant messaging using quantum internet or quantum technology is not possible. So what does that mean? Quantum internet is not fascinating? No. Quantum internet actually is fascinating, but aspects are different. That is not actually instant communication, that is different thing. Instant correlation, that is possible. Instant communication is not possible, but instant correlation. You are you are measuring the state of one particle and that instantly changing the state of the other. That is what? That is instant correlation, and that is actually used in quantum technology or in quantum communication. Instant detection of hacking, that is possible. Instant detection of hacking is possible. If someone tries to eavesdrop, then immediately the intrusion is detected. So these are the things which are possible, and these are most desirable in case of defense communication systems, in case of banking, secure banking. That means for what? For unhackable communication system, for ultra secure data transfer, quantum internet is the requirement. Using quantum key distribution or QKD, two users can share encryption keys in a way that's physically impossible to intercept without being detected. Yes, that is called QKD or quantum key distribution. For this thing, I'll make a separate video. Then, if a hacker tries to eavesdrop, then what is the requirement? A requirement is to disturb the quantum state. And whenever the hacker tries to disturb the quantum state, that is actually immediately detected. Means that intrusion is immediately detected. And the same thing means researchers in China, the US and Europe, they have already demonstrated what? They have already demonstrated these networks. Okay, actually China's Micius satellite. Okay, there were ground stations thousands of kilometers apart, and they share the quantum key successfully between those ground stations. So you can see this technology is evolving fast, this quantum technology. Okay, that means these countries, the US, Europe and China, they have demonstrated what? Small scale quantum networks using fiber optic links and satellites. And China, they have used their Micius satellite to do the same thing. So ground stations were thousands of kilometers apart, and they share that quantum keys successfully between those ground stations. So you can see, by using this quantum internet technology, instant messaging or instant communication, that is not possible, but many other very important things are possible. Unhackable communication, that is the most important thing, that is possible. Instant coordination is possible. Instant detection of intrusion or instant detection of hacking, that is also possible. And this is the requirement in banking industry, means in secure banking. In case of defense communication systems, this is also desirable. Okay, anyway, that means, and actually what is happening here in quantum communication or quantum internet, the very laws of physics is being used, not just the passwords. Passwords are easily hackable, but they are actually using, means scientists are actually using the very laws of physics. Okay, in this technology of quantum internet. That's why if a hacker tries to eavesdrop, that is immediately detected. Anyway, so this was all about today's topic, and for that thing, that is QKD, quantum key distribution, that is the most interesting topic in this field. For that thing, I'll make a separate video. Anyway, so this was all about today's topic, and this is the end of this video. If you found this video fascinating, so please like, share and subscribe to our channel. This is the end. Thanks for watching.